What a difference a year makes. Today, exactly 12 months after launch, ESA's Hera mission for planetary defense is cruising safely through deep space. The car-sized spacecraft is currently far from Earth.
Well, in ESOP, we've had an absolutely amazing time operating Hera and looking after it over the past year. Right now, on its birthday, it's really far from us. It's on the other side of the sun, 500 million kilometers away from Earth, but we are still in touch, and it has been behaving really well so far.
Just a year earlier, things looked very different at Cape Canaveral, when the team wasn't sure if Hera was going to lift off at all.
48 hours before launch, we still had no approval for launch because the launcher was grounded because of an anomaly a few flights before. And we were finishing the thermal blankets, we were finishing uploading the software and fixing still some software just a few hours until launch. So it was totally crazy. And at the same time, news were telling us that a hurricane, Milton, was heading exactly in our way.
This was the most intense Atlantic hurricane ever recorded over the Gulf of Mexico, headed straight for Cape Canaveral. Locals boarded up windows and stockpiled sandbags.
So on launch day, we woke up at 5. At 6 o'clock, we were on the base and it was just pouring rain. So the first briefing, we had only 15% probability or chance of launching. But nevertheless, we agreed to go on the launch pad because the hurricane was coming and that was our last chance. Otherwise, we would have had to put the launcher back into the hangar.
Delaying wasn't an option. Hera needed to line up with Mars for a vital gravity assist to speed its journey to the Didymos binary asteroid system. Any slip now would have delayed the mission by a matter of years. This would be too late for Hera's planetary defense goal, checking exactly what happened after NASA's DART spacecraft crashed into the smaller asteroid back in 2022.
Finally, there was a miracle. Half an hour before launch, a storm was coming far away enough for us to launch, and at that moment the auto sequence started and we launched. So that was a lot of joy, a lot of tears, a lot of excitement, and finally, literally as Milton was approaching, the satellite was in space and we were heading towards Didymos.
The action shifted to ESOC, where ESA's operations team took control. They'd been holding their breath to see if Hera would make its tour. Acquisition of signal from space confirmed they had a mission. As Hera sped away, teams across the world powered up the spacecraft instruments, capturing images of Earth and the Moon. In the process, the team performed the very first test of the self-driving technology that Hera will rely on around the asteroids, performing centroid tracking of these two bodies. The next mission milestone came in the spring of 2025, as Hera came as close as 5,700 kilometers away from Mars, the planet's gravity shifting the spacecraft trajectory towards its final destination.
In March this year, Hera flew by Mars, and also one of its moons, Deimos, we could observe during this flyby. It was a very fast flyby, so Hera flew by within 30 minutes of the system, and in this period, we took the chance and the challenge to take a lot of images of Mars and its moons for a scientific purpose. So our cameras were active and were imaging at a high frequency, as it will be during the asteroid system, but also from a navigational perspective. We used one of our so-called feature tracking modes, where Hera is seeing features on the surface of Mars and analyzing that and tracking them over time, through which it can keep on pointing its cameras on the Mars surface. And this is one of these key features we will be using when we are very close to the asteroid system.
Moving at 9 kilometers per second relative to Mars, Hera was soon on its own again, gradually gaining on Didymos. Back on Earth, the mission team are still keeping busy, checking in regularly on Hera and preparing new software for upload as the cruise phase continues.
This is the first interplanetary mission we have the chance to work on, and what a first mission it is. And we get to do this alongside very experienced people that worked on impactful and ambitious missions like Rosetta. So this was an absolute privilege so far.
In May, Hera captured its very first asteroid image, of asteroid Otero, visible as a bright dot from 3 million kilometers away, confirming the sensitivity of Hera's asteroid framing camera. Meanwhile, the Japan Aerospace Exploration Agency, JAXA, a mission partner, confirmed that their own station antenna can communicate with Hera in deep space. Back in Europe, the mission operations infrastructure for Hera's 2 CubeSats is being set up.
Hera is carrying 2 CubeSats. These are nano satellites, if you want. They're the size of a shoebox. They will complement the science acquired by Hera, because basically they're allowed to take more risks. They'll go closer to the binary system. So all the data exchanges, so instructions to the CubeSats, but telemetry back from the CubeSats flows through Hera, then to ESOC here in Darmstadt, and then we transmit all this to what we call the CMOC, which is the CubeSat Mission Operations Center. Right now the CubeSat Mission Operations Center is going through its design review, and we're following this closely.
Hera is scheduled to reach the binary asteroids in autumn 2026 and may even catch its first glimpse of the pair next summer.
At the same time, we're preparing for 2 new missions. One is Comet Interceptor, which will basically be launched, go to a parking orbit and wait for a pristine comet to show up, and then we'll go and visit this comet. Comet Interceptor is reusing a lot of software from Hera, for example, and all the ground processes we are using for Hera we will adapt for Comet Interceptor. And the next mission is Ramses. So this is basically a carbon copy of Hera. We have 1 year less to build Ramses before launch from 2028. And the idea is to be with asteroid Apophis, which will fly by Earth on Friday the 13th of April 2029 at a distance below the geostationary ring. Yeah? So there's no risk of collision with the Earth, but the asteroid will be so close that here in Europe, it's around 2100 in the evening, we'll be able to see it with the naked eye.
The mission team remain busy. Next, Hera is headed to the coldness of Apollyon, its furthest distance from the Sun. At around the same time, ESA's Council of Ministers will be making the go, no-go decision for Hera's follow-on Ramses mission, ESA's next asteroid adventure.